Hello and welcome to this third semester project of medialogy in C++. Um, my name is Sebastian and I'm going to show you my project, assignment 3. First off, this is the libraries that I include, the IO stream and CMath, going to use some math later, and the CST library, which is so I'm able to do some random numbers. This is the main function. I'm starting here to define some variables that I use in the project, some dice, some max row number, and I'm going to explain those later, what they do. Okay, first of all, 4 dice, have to roll them 30 times. That's why I'm doing it in a for loop, to do it 30 times. First of all, I'm going to loop it the first time, and I have a double for loop because first of all I'm doing a random throw with the dice. I'm going to do that 6 times, which is defined here. The number of dice is in this case 4 dice, and so I'm going to roll this random number 4 times, 4 dices, and here I'm having a sum which sums up all the dices, and since I'm using modulus 6, I have to plus 1 such that I don't get any zeros, but get any random number from 1 to 6. After I've thrown 4 dices, then I'm putting the value inside my dice array 4, because we want them in a big array, all the 30 values. After that, I'm resetting the sum, and then it loops back again, throw 4 dices, and so on and so on. At the same time, it couts the array here, such that we can see it in the output which values we get. And again here I'm just arguing in the output window. Yeah, to calculate the mean values for these 4 dices and to do any calculations with them statistically, we need to sort them. And I've chosen to do a bubble sort, which can sort the numbers. It's in a double for loop, and here is the if statement that if the one on the left is bigger than the one on the right in the array, then they will switch place. So we swap them here, and so on and so on and so on, such that we get a sorted array from. Actually, this array starts with the biggest number to the smallest one number. Yeah. But that doesn't really matter. Okay, this is the sorted values. I'm printing it out. I'm going to show you the output window later. First of all, I'm going to calculate the median value. I'm doing that by, well, you can take all the numbers in the array, which is 30, and divide them by 2. But I'm cheating a bit, so I know that these 2 positions in the array is the 2 middle numbers, which is the median. And I'm putting those together, dividing by 2 to get an average of those 2, which is going to be the median value. The mean value is of course done by putting all the values together and dividing them by 30. And this is also, of course, where I should explain this total value that I've put in the bubble sort. I could have put it in elsewhere, but I've chosen to put it in here. It pluses 1 with the array, which means it starts at 0, but it sums up all the values, you could say. I am sorry for not explaining that earlier. So as you can see, I'm just dividing it by the roll number, and thence the mean is created. Standard deviation, first of all, want to create a variance. To do that, I'll take the numbers of the array in a for loop, so each value of the array, and minus the mean value of the dices, and times itself, you could say, because I haven't got it squared, so that's why I've done this. Once we got that, we here we I'm dividing it by, I'm taking the total value and divided by the roll number minus 1 to get the total variance. We are going to use the variance for this standard deviation, which is the total variance squared, and that's what I'm stating here. And then I see out it once here to get a good overview. Actually, I have done the same with 5 dices. Didn't want to mess anything up, so I've done the 5 dices alone here, and it's pretty much the same as with 4 dices. I bubble sort them again, and I'm taking the median, the mean, and the standard deviation. Yeah, it's basically the same. At the end, I'm doing the student's t-test, which is the mean values of both sums of the dice, both 4 and 5 dices, and these are divided by the square root of the total variance divided by 30 and plus the total variance divided by 30. So we get the difference. Let's see if we